A large language model operating in isolation is just a prediction engine. It calculates probabilities to generate a sequential stream of alphanumeric characters, completely blind to the world outside its computational void. Intelligence is not the same as agency. A model can output the exact syntax required to build a complex web application, but on its own it cannot execute code, navigate a file directory, or iterate on its own errors. To bridge text generation and system interaction, you need a harness. Here, our core model, the LLM brain, sits isolated. The harness acts as a nervous system, wiring the brain into a local file system, a secure sandbox, and external tools. The harness is what enables the transition from a static, text-based conversation to an iterative execution loop. Industry-standard coding agents like Claude Code or OpenAI's Codex rely on strict closed-loop architectures. The developers of the model completely dictate how the surrounding harness operates. DeepSeek recently released a competing framework built on a system called Cordis. Their design rejects that monolithic structure. To understand the mechanics of this, we have to look at DeepSeek's technical paper on spatiotemporal composability, a design philosophy where every functional piece of the agent is treated as a hot-swappable plugin. This release suggests a shift in how AI environments are constructed, prioritizing developer customization over proprietary lock-in. This block diagram illustrates a traditional harness execution loop. A central while loop node is encased within a solid border. The process cycles. The model predicts, the tool executes, and sandbox output feeds back. These components are permanently fused together by the provider. This tight coupling forces developers to rely on the provider's specific execution environments. If their default sandbox is unmaintained or inadequate for your particular codebase, you cannot swap it out. The system suffers from structural lock-in. The components are fused together under pressure, unable to adapt to external engineering demands. Monolithic architectures can bottleneck advanced workflows by taking system design choices away from the system's architect. DeepSeek's architectural thesis resolves this bottleneck through a concept they term spatiotemporal composability. To achieve this, the rigid monolith is dismantled into independent packages. Spatial composability means components are interchanged anywhere, while temporal ensures dependencies can be swapped as project requirements evolve. The underlying engine driving this modularity is the Cordis framework. Under Cordis, the adapter, tools, UI, and sandbox are distinct plugins mapped through a single configuration file. Even the central execution loop is treated as a swappable plugin, replaced by altering a single line of text. By isolating every functional piece as a separate dependency, the developer regains control over the agent's operating environment. In practice, to bypass a restrictive sandbox and hook up a custom environment from an open-source repository, you only need to update one line of YAML. This structural efficiency scales. In testing, this harness orchestrated the generation of 2.6 million tokens to build a full web application from scratch. But managing an autonomous system at that scale introduces a telemetry challenge. Tracking millions of sequential tool calls requires organized visual logging. DeepSeek's solution is the trajectory panel. It acts as a vertical timeline, mapping specific reasoning steps into discrete tool calls. Like a software stack trace for an AI's cognitive process, you can trace any error directly back to the triggering step. Engineers can pinpoint the moment an agent execution loop hallucinated or fed an incorrect command into the file system. When you pair a modular harness with detailed trajectory telemetry, AI debugging shifts from a black box guessing game into an exercise in systems engineering. By decoupling the core components of the agent, the harness moves away from rigid, fixed-loop designs towards a network of dynamic, independent components. Agent development is beginning to diverge from closed, proprietary loops in favor of customizable ecosystems. By placing the two architectural approaches side by side, the contrast is clear. On the left, a rigid monolith. On the right, a dynamic, YAML-driven network. This architecture mimics the philosophy of Linux, providing a foundational, open operating environment for AI agents. An AI model's raw intelligence is ultimately limited if its surrounding harness cannot be adapted to its specific engineering environment. Assessing a system's true capability no longer means simply benchmarking the model's token predictions. It demands evaluating the composability